series motor. This is the supply voltage. This is the load current, that is also series field winding current, that is also armature current. So in case of series machine, load current will be equals to series field current, that is also equals to armature winding current. Total supply voltage will be equals to back EMF plus IaRa, that is the voltage drop across armature winding, IaRSC, that is voltage drop across series field winding, and brush voltage drop. So whenever current passes through this series field winding, flux will produce. This flux links with the armature conductors and force will establish. Force will be BIL sin theta. B is as per the flux, current in the armature conductors, length of the armature conductor, and angular momentum of armature conductors. And load will be on the shaft. And from the basics of DC machine, power equals to torque and speed, power equals to voltage and current. So torque will be directly proportional to flux and current. Back EMF or generated voltage E equals to directly proportional to flux and speed. So the relation between flux and speed is inversely proportional relation. The flux can be replaced with current. So from these relations, speed is inversely proportional to flux. So here is the flux. Flux means flux produced by the main field windings. Flux will only produce when current passes through these field windings. So flux is directly proportional to current in the field windings. And here the current is common. Load current, series field current, armature current, all the currents is common. So the basic is speed is inversely proportional to flux or speed is inversely proportional to current. So for lower the fluxes, speed will be very high. Under ideal condition, if the flux is 0, then speed will be infinite. This is ideal condition. In case of series generator, we were having load in place of supply. In case of series motor, the load is on the shaft. As per the relation between speed and flux, for lower fluxes, speed is very high, so that this series motor should not be started without load. There must be load on the shaft of the series motor. This is very important note. So if it is series motor, then load must be coupled always. If load 0 means flux will be very low, speed will be very high. So coming to torque, torque is having two states. One is before saturation, second one is after saturation. So saturation means saturation of field poles. So before saturation, the torque is directly proportional to flux and current. The flux is directly proportional to current. So torque can be taken as current into current, which is torque is directly proportional to square of the current. This is before saturation. After saturation, the torque is directly proportional to only current, because the pole is saturated and there won't be any additional of flux. So flux will remain constant. So after saturation, torque will be directly proportional to only current. So these are the two conditions. One is before saturation and this is after saturation. So before saturation, the torque is directly proportional to square of the current. After saturation, torque is directly proportional to only current. That means initially there will be very high starting torque. So this type of series machines mainly used in traction applications, where high starting torque is required. Reversal of rotation. This is the same method for all type of DC machines. For reversal of rotation, we have to reverse either field winding or armature winding, but not both. So this is field winding and this is armature winding. We have to reverse either any one. If we reverse the both, so there won't be any negative torque. So this is field current, armature current. Initial conditions, torque is assumed as positive. If any one of field is reversed, that means the current direction in that winding will be reversed, so that torque will be reversed. If both windings are reversed, that means current directions in both the winding is reversed at the same time and the torque will be same as previous condition. So for reversal of rotation, either any one has to be reversed but not both. So when torque is reversed, torque can be reversed immediately at t equals to 0 plus, but whereas the speed will not change immediately. Speed has to decrease gradually and cross 0 point and then goes into reverse direction. This is counterclockwise direction. This is general direction of motor. Reversing the direction means we are rotating the motor in clockwise direction. So at 0 speed, braking is possible. So this is forward motoring mode and this is reverse motoring mode. So here torque is reversed immediately, but the speed is not reversed immediately because the torque develops reverse forces. These reverse forces must overcome the moment of inertia of rotor. Coming to curves, speed curves, torque curves and speed torque curves. So from the general relations, speed is inversely proportional to flux, which is also equals to speed is inversely proportional to current. So for lower the current, the speed will be very high. For higher the current, speed will be very low. So this is the speed curve, speed versus armature current curve. Basically, this is rectangular hyperbola shape, very poor speed regulation. That means for lower the current, higher the speed, higher the current, lower the speed. So the speed variation is very high. So that speed regulation is very poor. So this is quadrant 1, forward motoring mode. Quadrant 3 will be reverse motoring mode. Torque curves, this is having two stages. One is before saturation, second one is after saturation. So before saturation, the torque is directly proportional to square of the current. After saturation, the torque is directly proportional to only current. So the curve shape is like this: before saturation and after saturation. After saturation, the curve is linear. Before saturation, the curve is parabolic. So this is armature torque when armature reaction is ignored. When armature reaction is considered, the torque will start at origin and there would be slight deviation. And this is shaft torque. Shaft torque shifted because of frictional losses. So this is the shift of shaft torque. Finally, speed and torque curves. Torque is also directly proportional to current. So speed torque curves are very similar to speed and armature current characteristics. And from general relation, speed is inversely proportional to torque. So this is the curve very similar to speed and armature current characteristics. So this is a load current characteristic, efficiency curve and torque curve. So these are all performance curves. So these are the basics of series motor and important curves: speed curves, torque curves and speed torque curves along with performance curves.